Okay, so look, got a little thought exercise to begin with today. Let's suppose that you are, let's set the Wayback Machine for 1972. 1972. And you're like the manager of a bank. And you're starting to think you've heard of these so-called computers, and you think they might be useful to keep track of the information at the bank. There's lots of stuff to keep track of at the bank. In fact, before we started using computers for banking, did you realize that one day a quarter, most banks were closed for the purpose of applying interest to accounts? I'm going to go through by hand and calculate what is the interest that was accrued on this account during this quarter, and actually make a transaction that adds that into the books. But now you're thinking maybe we could use these computers to do some of those kinds of tasks. And so you've got it, right? You got your computers in here. And so now you're thinking we want to design the screen that we're going to use to do a deposit. This is a walk-up deposit. Somebody is walking up to the bank, has got cash money, and wants to deposit it into a particular account. Oh boy, computers in the 1970s weren't very powerful. Like the phone that you have in your pocket is like as powerful as all the computers in the world put together in 1970. I mean, maybe not quite that powerful, but these things are not very powerful at all. And here's the big thing. It takes a long time to read data off of a disk. And so, and if we're having to transfer data, from this branch of the bank to another branch of the bank, forget it. I mean, we can do it, but that's a really slow process. And so, what information do we need to capture to be able to do a deposit? We want to keep this as lean as possible. What information do we have to make a deposit? I'm giving you a hint. I got two things showing up here right now. What are they? Go ahead. Account number. Account number, you got to give us an account number and what? Amount. Great. There's not even a button for enter because there's no mouse. You're just going to type those things in and hit some key on your keyboard, which may be enter, it may be something else. Maybe a key that says commit. Keyboards look different in the 70s too. We had big hair, bell bottoms. It was a bad time. Okay. Now, let's think about what could go wrong in the world of data entry, because we got tellers working these computers. They're a little bit nervous to even touch them in the first place, and they're our lowest paid employees. So what could go wrong in this situation? There are two big things that can go wrong. What are they? Go ahead. You could type in the wrong account number, or you could type in the wrong amount. Those are the two big problems here. Let's, for a minute, talk about what we might do to make sure the account number is right. Any thoughts? We'll forget amount for now. Let's do account number. Go ahead, we'll hear from you, and then we'll hear from you. Okay, so we know a set amount of numbers. We know that our account numbers are 6 digits long. And so we can check to see, is it 6 digits long? So that's something. Give us 5 digits. That's no good. You give us 6. Okay, I like it. So that's good. What else? Okay, something that says, are you really sure? It won't be very long before we see that message and we go, yeah, I'm sure. I just typed it in. So that probably won't help, but so something there. Go ahead. Okay, we're headed there. That's the example. So you said that too soon. So pretend you didn't hear that. What else might we do? Say it again. Okay, could have them enter it twice. Entering it twice works pretty well if we've got like a bunch of numbers. So if we could enter a whole bunch of numbers and then go enter all those numbers again, then the chances of us hitting that same number wrong is a lot lower. But if we just type the same one in twice, that's okay if the mistake happened between the brain and the fingers. But if it happened between the eyes and the brain, if it happened on input, then if we read it wrong, we'll type it the same way both times. So that doubles the work, and it might give us some improved benefit. So that might be helpful. It's a good thought. Okay, we could check against the database to see if it's a valid account number, or we could actually look up the person's name and bring that back from the database. But the problem is, in the 1970s, that's really expensive. It's prohibitively expensive, especially if the database is off-site. Right? If it's a database sitting in our own building here, okay. But if it's off-site, that would take too long. It might take 30 seconds for the round trip to happen for us to be able to say, oh yeah. So you type in the account number and wait 30 seconds. 30 seconds is a long time. You can make a quesadilla in 30 seconds. Yeah? Not long enough for nachos. I know this. 45 seconds for nachos. Quesadilla 30 seconds. Okay. So, yeah, so we need something. In fact, someone mentioned this idea of a check digit. We're going to talk about that here in just a moment. It happens that my former colleague, Frank Abagnale Jr., anyone know Frank Abagnale Jr. here? Who says, I say that name and you go, I know what you're talking about. There's a few of you here. He claims, it was before my time, but he claims he actually took a position on the faculty at Brigham Young University, even though he didn't have an advanced degree of any kind and taught psychology classes here for a number of terms. The university, incidentally, denies that. I don't know who to believe in this situation. He was the central character in the book Catch Me If You Can, also then made a movie. You know, if someone makes a movie about your life and Leonardo DiCaprio plays you, that's pretty good. Pretty good deal. I watched a talk by Frank Abagnale Jr. later. He doesn't look anything like Leonardo DiCaprio. I don't think he ever did, but there you go. This was his first financial instrument fraud, was this very thing. He noticed that when Edna went into the bank to deposit her Social Security check or whatever check she's depositing, she would walk up to the counter, and there's a thing called the deposit slip, a counter deposit slip. Listen, do any of you have checkbook? How many of you have a checkbook? Oh, it's like not even half. That's great. Those of you who have checkbooks, in the very back you have deposit slips. We don't almost never use deposit slips anymore. We just go in, give them the checks, they type them in, and we're okay. But it used to be you had to have the deposit slip, and if you wanted to make a deposit without your checkbook, you didn't have the deposit slip, that's okay. They've got deposit slips sitting there in the bank. You just go pick up a deposit slip, you write in your account number. I mean, the ones on your checkbook are pre-printed, but you write in your account number, you put in your name, you put in the checks and whatever you're depositing, you take it to the counter, and they do it. It's all part of these documents they're keeping. Well, he noticed that Edna didn't write her account number onto the slip. And so when Edna got up, she didn't know her account number. When she got up to the teller says, oh, hello, Edna, it's good to see you again today. Let me look up your account number for you. She would look it up and then enter that account number to make the deposit. But if the person had the account number written in, what does the teller do? Types it in. Frank goes into the bank and he picks up a stack of these counter deposit slips, goes back to his apartment and rolls them one at a time into the typewriter and types in his account number. Gets a whole stack of them, goes back to the bank and puts them back on the counter in the bank. So now when Edna comes in, she takes the deposit slip, she writes her name and address the way she always did. She goes up to the teller looks at it and types the number in, and the money goes into Frank's account instead of Edna's account. After 2 weeks, before a whole cycle has, transpired, that people will realize, hey, how come this didn't show up in my statement? He closed the account, takes the money, and walks away. He was really kind of a clever fellow, not in a role model sort of way, but anyway, where is he now? Do you know where he's still alive and gainfully employed? Do you know where he works today? Yeah, he works for the FBI, catching the kinds of, he has a mind that can think the way criminals think. What's that? Catching, other versions of himself. He was actually the most brilliant thing I think he did. He was the first criminal to figure out that if you fiddled with the routing number on the bottom of a check, like if you made a check, printed a check, and the routing number, instead of routing it to the West Coast, route it to the East Coast, it would take weeks for that check to clear. And when we deposit money into a bank in the day, before it clears, what do? We assume that it's there. And how do we know that it's not there? The check comes back to us. And so we would say, we're going to need a 3 or 4 day hold on this check because that's how long it takes for us to get the feedback that says this check didn't clear. And we assume that if it doesn't come back, it clears. And so you've got the money in your account and it's at your disposal. So he actually would print checks with the routing number that, for a check that should clear in San Francisco, would send it to New York. And it would take weeks to ever find its way to where it belonged. Yeah, kind of amazing. Okay, enough about Frank, and let's talk about the solution. So here's what we did. We say, let's suppose our account number is 1, 2, 3, 4, 5, 6. We got a 6-digit account number. The very first thing that we did to try to make sure this was typed in right was we said, listen, let's do this. Let's just take those 6 numbers and let's add them up. That's 21. And let's just actually make that a part of the account number. So now our account numbers, instead of being 6, they're 8 digits. So when you type in the account number, The computer can now look at that and can take, all right, we got 8 digits. The first thing we're going to do is the right number of digits. Right number of digits. Good. Now we're going to run an algorithm on those digits, and we're going to find out, did the first 6 digits produce the last 2 digits? It's a really simple algorithm. Just add them up. And does it give us a say? If it does, we go, great. That's a well-formed number. Now, that's a lot better than just typing in and hope it's right. Because now if I make a mistake in those first 6 numbers, I have to make a corresponding mistake in the last 2 numbers, for that to accidentally come through as a right account. I have just dramatically reduced the probability of typing an incorrect account number in there. Now, what's the problem with this approach? There's a really common data error that this doesn't fix. Yeah, 2 sequential digits transposed are going to produce exactly the same one. And that's like one of the most common errors. Probably the most common errors is typing an extra one because you actually hit a key different than you meant to hit. But maybe the next most common one is transposing 2 sequential digits. And this one doesn't fix that. And so, kind of after we saw that, hey, this is pretty good, but how can we do better, came the idea of a checked digit. So a checked digit is where you say the algorithm is going to be more complex than just adding up the numbers. But depending on the way that we do the math, we want to have 2 characteristics. Number 1, we want to be able to protect against any single mistyped digit, and we want to be able to check for any 2 sequential transposed digits. And on top of that, we want the result of that algorithm not to be 2 characters the way this one is, but to be a single character. That's why it's called a check digit. We want to come up with some mathematical approach that we can say, look at what's typed in here, and then see, did that produce the 1 digit that we have added into this account number just to be able to make sure it's done right. And so that's our task for today, is to implement the check digit algorithm for the 10-digit ISBN. What's the ISBN? International Standard Book Number. So if you got, anyone have a printed book with them today? A printed book? I don't know. There's an ISBN on the back. Up until early 2000s, ISBNs were always 10 digits. And now they're generally 13 digits. So we kind of had do you have both 10 and 13 on showing on that one, or just 13? On the barcode, does it show a number above it and below it? Oh, anyway, let's see. That's a 13-digit ISBN. So, and it's just shown in 2 different ways. So that's actually, you guys have similar books. Anyway, so that's the idea. So here's good news, folks. Today, we're going to do the 10-digit algorithm for calculating the check digit for a book number. Your next project is to implement the algorithm for the 13-digit ISBN. So the stuff we're doing today is going to be directly applicable to what your next project is. All right? So let's see if we can figure out what the algorithm is for doing an ISBN. ISBN, Wikipedia, don't let me down. Holy cow, am I zoomed in or what? Control minus. Some history, some overview. Oh, so there's interesting. So here's an ISBN. This is a 10-digit ISBN. And so there's actually different parts of the number mean different things. So apparently the first 2 digits mean something about a group. I don't know what group that is. But the next 4 digits identify the publisher. So that's the unique code for the publisher. And then we've got something for the title of the book, and then the check digit. Here's the check digit right there, the last one. So, here's the 13-digit ISBN. So it's, the nice thing about a 13-digit ISBN is that it brings it in to be a product code as well. So it's kind of in the same space as your stock keeping units that you use for managing inventory. Okay, ISBN, there's all kinds of ISBN. Here we go. The ISBN 10-digit calculation. All right. So here's the algorithm. Here's the number that we're trying to validate. So remember the account, so in an account number that has a check digit, it takes, however long the account number is, it takes 1 less character to identify the account. And the check digit, the last digit, it's just there so I can check to make sure the other digits are right. And so here we have a book number, 0306 4615, 400615. And now the question is, how do we calculate what the check digit is? And so let's go down a little bit more. And they kind of spell the whole thing out for us right here. So here it is. The algorithm looks like this. Let's start from the middle right here. It says, take the number 10 and multiply it by the first digit in your number. So there's 0. So that's the first part here is 10 times 0. Then take the number 9 and multiply it by something. Then the number 8, 7, 6, 5, 4. Each one of those numbers can be multiplied by something else. What is it multiplied by? 10 is multiplied by the first one. 9 is multiplied by the second one. So we have 9 times 3 here. Second digit's 3. 8 is multiplied by the third one. That's the 0 right there, is that 0. 7 is multiplied by the next one. So there's the 6. And so we take all of that whole sequence. So 10 times the first, 9 times the second, 8 times the third, and so forth. And we add those up, so some product. We add those up, and that gives us 130. So step 1 is we get that data there. And then we take that number mod 11. Mod? What does that mean? Right, it is take 130, divide it by 11, and give me the remainder. The remainder? You mean the decimal portion? No, not the decimal portion, the remainder. Remember when you learned long division in 4th grade, and you asked Mrs. Ransom, when will I ever have to use this? The answer is today. This is when you need long division. Is because we're working with the remainder, right? When you said, when you said 11 goes into 130, so you're drop this down, you do some, multiply that and subtract, carry it down, and you finally end up with a remainder. Go, aha, the remainder is 9. Or, what was the remainder? Yeah, the remainder is 9. The question is, why is it mod 11 instead of mod 22 or mod 4? And the answer is, some mathematician figured out that if we take this algorithm, it'll produce something that gives us the characteristics of a check digit, which are 2 things. Well, 3 things, really, I guess. So 1, it's going to be a single character. That's the result. And 2, it's going to protect us against any mistyped character and any 2 sequential transpose characters. And so some guy was just thinking, I wonder what happens if we take mod 11. I don't know how he thought of it. That's what he thought of. So that 130 mod 11 is 9. So now our whole thing is down here. We then take 11 minus that number, 9, which gives us 2. The next step is then we take 2 mod 11, which is also 2. And so the check digit, going through that whole process, the check digit is 2. So this whole ISBN then is just what's there plus a 2 on the end. So the idea is if we're going to create a function that will validate an ISBN. You give us an ISBN, or at least what you told us is an ISBN, and we will look at what you gave us, we'll run the algorithm, and then we will give you back true or false. True, it's a well-formed ISBN. False, it's not a well-formed ISBN. We can't tell if it actually means a particular book because there's someone else does the assignment of that number to a book, but we can tell you is it well-formed. We're really pretty sure you didn't mistype this thing. It's the one you meant to give us. Okay, so that's our task to do in the next 40 minutes. Ready to do it? Let's get down to business. I'm going to copy this example as, since we kind of have the intermediate steps here on Wikipedia, that's where I'm going to start. All right, so I must be editing a cell somewhere. All right, so I'm going to start off by inserting a module. It's always tempting a little bit on a blank workbook just to say, I'm going to build this on sheet 1. Don't do that. This needs to be on a general module. Go through the time to say insert module, and then that will give us a general module. For this function to work, it has to be in a general module. Instead of saying sub as making a sub procedure, we're making a function procedure. So we start off with the keyword function. I'm going to give it a name. I'm going to call it isValid ISBN 10. Now, the user is going to give us something to work on. I need some way to receive that. I'm going to make a parameter for that. And so I'm going to call this the candidate. I don't know if it's really an ISBN or not. They're giving me something to work on. I'm going to call it the candidate. What data type should we take this in as? Yeah, I like string. string. As a string. Now, remember that functions, we'll just ask this little question. What's the difference between a function procedure and a sub procedure? They are extraordinarily similar to each other. What is the big difference, the main defining difference? One might think the only difference. In the back? Oh yeah, so you can definitely, so with this function procedure we're creating, you can call this from inside of a cell, inside a worksheet. And that gets at the reason, but I want to hear the kind of the clearer definition of why, what is it that allows us to do that? There's a comment over here. It returns a value. So after it's done, it's both blocks of VBA code that execute and do something, but the function procedure, when it's done, it sends a value back to where it was called. So if we call it from the immediate window and we say print this, it'll say, okay, go figure out what that is. It'll send the value back and it will print it. If we call it from a cell and we say this cell's value equals the result of this function, it'll do the calculation and the value will come back and show up right in that cell. So because it returns a value, I have to give it a type. Just like variables have data types, functions have data types as well. What type do we like for this? It's going to return true or false. What type? Boolean. So Boolean is a data type named after a guy named George Boole, who was an 18th century mathematician who spent his career thinking about logical stuff. What happens if you have true and false, and these kinds of things? He worked with these logical values, and so it's named after him because it's logical value. So it's a value that is either true or false. This all looks perfect. Oh, I missed the as right in here. As string. Okay, now, one of the difficult things here, I'm going to go ahead and just run this the way it is. I'll hit play, and not only does it not do anything, it says, I don't even know what you're talking about. What macro do you want to run here? Why can't I just run this one? Is it because it's a function? It's not because it's a function. It's because why? That's right. It's expecting a value. For this thing to run, it's got to have a value given for candidate, and so you can't just run this one. So here's what we're going to do. We're going to come up here, and we're going to make one that we can run that just calls this one appropriately. So I'm going to make a sub procedure, and I'm going to call it my Acme function runner. This one I can run because it's not taking any arguments. And all I'm going to do is say debug.print. And then I'm going to call isValid ISBN 10. And I'm going to pass it the value that I want to work with. So I'm here passing it that string. Maybe I'll go ahead and put a hyphen before the check digit. So that's the ISBN that we took off of the Wikipedia page. So now this one can run because it's not taking a parameter. It doesn't have to have a value given to it, so I can run it directly. And now I call ISBN 10 and I give it what it's expecting. And so this value, when I call this function, will be written into the variable candidate right here. This is going to return a value. I'm capturing the value that comes back just by saying, I'm not capturing it, but I'm telling it where to go. Print that out to the immediate window. So this is not very interesting yet, but it is syntactically complete. So I should be able to run my Acme function runner. I called it Acme because I want it to be alphabetically small. So when I get more than one subprocedure in here, when I just am working on my function and I say run, it'll come up and say, oh, you must mean this one. That's the default one. It's the only other one here, so it can be named anything, but now I'll run it. And it prints false. Why false? Yeah, it's a Boolean type. Only two choices, true and false. And every data type has a default value. What's the default value for string? Zero length string. It's not very interesting, zero length string. Default value for integer? Zero. Single currency? Yeah, these are all zero. Default value for date? January 1st, 1900. It's got a default value there as well. For Boolean, the default is false. So if I don't ever tell it to return something else, it's going to return its default value. Okay, so step one, actually, step one here, we've got a little bit of trouble, and that is we got these hyphens in here. And if you look at ISBN, sometimes they have a hyphen, sometimes they don't have anything. It's just the numbers run together. Sometimes they got spaces, sometimes they have dots. I would like to just ignore anything that's not a number. When you put a capital Q in there, ignore it. That's what I do. So let's, actually before we're on our way to that, but before we do that, let's treat the check digit itself. And unfortunately, this check digit, this is not the best check digit algorithm. Okay, it was the 1970s. We weren't very good at this yet. And so I look at this very last step. I've got some number, mod 11. What are the possibilities? What's the range of the result of that part of the function? It could be anywhere from 0 to 10. Yeah, I can't get 11 out of a mod 11 function because you can't have a remainder of 11 if you're dividing by 11. It would just be one more in the quotient. And so I got 0 through 10. Now I can represent 0 with one character, 0. I can represent 1 with one character. I can represent 8 with one character, 9 with one character. How do I represent 10 with one character? Say it again. X. In what language does X mean 10? Roman numerals. Yeah, there's a way to say to say 10 with one character, and it's X. And so if you look at some of the old ISBN 10 numbers, you can look at older books to find them, and approximately 1 out of every 10 ISBN ends with an X. And if you ever worked like in a bookstore on the 10 keypad for your computer where you're typing stuff, it wasn't a 10 keypad, it was an 11 keypad because they gave you an X over there. So you could type it just on you're typing the rest of the numbers. Like seriously, people developed hardware to be able to support the use of this particular algorithm because it was so pervasive. So good news. The 13-digit ISBN check digit is a little more sophisticated, and it only has 0 through 9. So you don't have to worry about dealing with X in the project. But we have to deal with X here. So we're going to make a simplifying assumption. This is a simplifying assumption you should not make in the project because it's meaningless in your project. So don't just kind of look at everything I did and kind of convert it over and go, yeah, this will work for 13, because how you handle the check digit is going to be different there. So we're going to assume that the last character is the check digit, even though I would prefer to be able to take this. I'd prefer to be able to take that with a space on the end and be able to say, yeah, I can figure that out. But to be able to get done now in the next 30 minutes or 25 minutes, we're just going to assume that the last character is the check digit. So let's give myself a couple of variables in here. I'm going to dim something called CD, that's short for check digit, as a string. I'm going to dim something called book number, BN, also as a string. And I'm going to start off by splitting this candidate that's being passed in here. I'm going to start off by splitting that into these two parts. All right. We saw the stuff that it takes to do this last time we got together. I'll get us started. Someone tell me what VBA can I use to put the check digit, the proper value into the check digit variable, the CD variable? What function? Right. Okay. Now what do I put for the first argument? The string I'm using, which is candidate. Very good. Because remember, when I call this function, isValidISBN10, I'm sending it this string. That string will be received in this variable that I defined right here. When I define a variable in the definition of the function, it is called a parameter, but it's still a variable. And so my candidate is going to be what has the candidate ISBN in it. And then what's the next argument? Yeah, I want the rightmost one character from the candidate. Now, getting the book number is a little more difficult, but not too bad. Someone help me with this one. BN equals what? The left of the candidate. I got to tell it how many characters I want. Here's the part that's a little more difficult. How do I do it? Yeah, it's the length of it minus 1. So if I got 20 characters here, I want the 19 from the left. So take the length, subtract 1 off of it, and we're good to go. So len of candidate, subtract 1. I'm going to put in here a statement I'm not sure we've talked about yet called stop. Stop will just say, at this point, just suspend the execution of the code. The variables are still defined, they're still in memory, and I should be able to take a look at them. So I'm going to run this, push play, and run. And so now I should be able to come to my immediate window, and I should be able to look and say, hey, what is CD right now? It's 2. That's what I expect it to be, the very last character. What is my book number right now? Book number is 0 through the hyphen after the 15. Yeah, that's what I'm expecting. That's great. So I've now split this into the two parts. Now, what I'd like to do with the candidate, or with my BN at this point, is I want to get rid of anything that's non-numeric. So, and I don't want to have to anticipate it. I don't want to have to say, get rid of all the hyphens, get rid of all the spaces, get rid of all the dots, get rid of all the capital A's, capital Q's, lowercase a's, lower q's. I want something that's a little more general that I can just say, get rid of anything that's non-numeric. This is actually quite similar to the example that we finished with when we were together on Monday. Remember, on Monday what we did, we made a function called supertrim, which said, you know what, I just want to get rid of anything that's non-printable. If it's below 32 or above 126, get rid of that and just give me what's left. Something similar here, but now what's the decision? We're going to keep it if it's a number. And fortunately, there is a function built into VBA that will tell me if something's a number. It is called isNumeric. I give it a string argument, and it will tell me if it can look at that string and convert it into a number. So isNumeric 300 or 3,333? True. Yeah, that's a number. How about 33.3? True, that's a number. How about 33.3a? False, that is not a number. How about 33.3 space? I don't know. What do you think? Number or not? I think false. I'm not sure though. Yeah. Oh no, it figured it out. It got rid of the space on the front. That surprises me. But anyway, it's looking at it and can figure it out. What's that? Oh yeah, I agree. If I put that space in the middle, it's going to go, that's no longer a number. That's false. Okay. But one other interesting thing here is let's get rid of everything except the dot. Now that's a character that's valid in a number, but is it a number? No, it's not. So it looks at that and goes, that's not a number. Okay, so that's good. This is kind of built in, so that's going to help us here. So we haven't got very far into this one before we decide, we need to make another function. So let's come down here and make another function just called, I'm going to call it numbers only. Numbers only. And I'm going to pass it in some data. I'll call it just data as a string. And it's going to return, what should we return? What data type should we return? What's that? Okay, integer would be okay as long as I'm dealing with numbers that are below 32,000. And my check digit is going to be like 9 characters, so integer is no good. Because there's only like 5 characters for integer. So long, that's going to get me up there, plus or minus 2 billion. Is that big enough? No. So because I can go 9 characters, is it 9 zeros for a billion? So maybe we could get it work. There's another reason why. Okay, so how about double? Let's go all the way to double. No good. And here's the reason. Let's think about the number that we're looking at right here. Let me go ahead and kind of pass in the one that we've got here. Numbers only. And let me pass in just what we have for our candidate, what we're going to be passing down to it. And it's not the whole candidate, it's just the book number portion of it. Let's suppose this number comes back, this comes back as a number type. How many digits will it have? It will not have 9 digits. How many? 8? Why 8? Yeah, if this comes back as a numeric variable, the leading 0 is going to be gone. And so we got to preserve that leading 0. So what type should we return? Yeah, it's got to come back as a string. There's really not a whole lot of choice here. We could do variant as well, but let's do string. As string. Okay, this is so close to the example that we did at the end of class last time. I'm going to go through it pretty quickly here. So I'm going to need a few variables here. I'm going to dim x as an integer just to be able to, I have to look at every single character and decide, is it a keeper or not a keeper? I'm going to declare a variable called keep as a string, where I'm just going to keep the characters that are keepers. And I'm going to dim one char as a string, just to allow me to kind of isolate and work with one character at a time. It'll just make my code a little bit easier to read. I got to look through every single character in data. So for x equals, start at 1 and go to what? How do I know how far I should go? Yeah, the length of my data. I'll put my next in here. And we'll go ahead and assign one character to be one particular character. So one char equals mid. I'm looking at my data variable. The first time through the loop, I want to look at the first character, second time the second character, third time the third, and so forth. So I'm going to look at the xth character, and I'll bring back just one. So each time I'm dealing just with one character, but I'm starting in a different place each time I go through the loop. So now I just want to check to see if is numeric. One char. Then we'll do something. What do we do? Well, we're going to take keep, and we're going to set that equal to what it used to be, concatenated with that character. So now I'm looking at that first character. Is it a number? It is. Great. It gets appended onto keep. Now keep is a string, and so it starts out with the default type for string, or the default value for a string, which is an empty string. So the first time I'm going to say keep is going to be an empty string plus one character, which is just going to be that first character. Second time through, it'll be whatever is there, appended on with whatever is next. Now the only thing I have to do is tell it the value to return. So I'll set the name of the function equal to my keep variable, which is where I'm keeping track of the stuff I'm trying to keep. And that should do it. So now, if I come to the immediate window and I call numbers only and pass it that sequence, it should be everything except those hyphens. I put in a capital Q in there, should get rid of the hyphen. Even if I put in like a capital 0, which looks a lot like a capital O, which looks a lot like a 0, it knows that is not a number. That is a letter. Okay, so this will be handy. So in fact, I think I'm ready to say I want to take numbers only and just say my book number is going to be equal to what it used to be, or rather, call to numbers only and send down the book number. So I've got my book number, send it down to numbers only. Numbers only doesn't change the book number down there. Numbers only just takes the book number as input, and it sends something back. It's up to me to tell it I got to overwrite the book number with it. And so the old value that I had for book number will now be kind of the new value here. So I'm going to run this to this point. And now if I look at book number, I can see I've gotten rid of those hyphens out of it. So I'm feeling pretty good. So really, I'm pretty close here. I've separated the two parts. I've got my check digit in one place. I've got now the other digits that I have to work across in the other place. Before I start working through the algorithm that we saw on Wikipedia, is there any check that I could make at this point and say, oh, you know what? I can tell already. This is not a valid number. What could I do? In what case could I look at this and go, you know what? Not a valid number. Go ahead. Okay, so after all, folks, it's called a 10-digit ISBN. So I need a total of 10 digits. Now, one of them is set aside in my check digit. So if I'm looking now at my book number, just everything besides the check digit, how big should that be at this point? Yeah, if this is a valid 10-digit number, that has to be 9 characters. So we can do that little check right here. Here's what I'm going to do. I'm going to say if the length of the book number is different from, that's how I say not equal to, is less than, greater than, is not equal to 9. Then we want to do something. What do we want to do? Exit the function. I'm just done. Get me out of here. It can't be valid. What will this function return if I never tell it to return true? It will return false. Yeah, so unless I tell it to return true, it's going to return false. And so here, if it's not 9, it can't be right. No reason to keep looking. And it's not just that we're thinking, yeah, I'm being kind of lazy here, I don't want to look over it. Now, once we get past this line, if we ever make it down to here to where my stop is right now, then we know there are 9 characters. That's nice. Because we know there are 9 characters, we can just say, look at all 9 of them. What would happen if we said, look at all 9 characters and there was only 8? That's an error. Well, look at the 9th character, there's only 8 to choose from. That's an error. And so this is really nice. We can say now, at this point, we know there's 9 characters, so we can just go ahead and look through all of them. Let me go ahead and make a call to this function. I'm going to stop this. I'm going to call it with the whole thing here, and the code should make it to the stop. Yeah, see, it made it past this. It stayed in the function and hit the stop. I'm going to take off the leading 0 and run this again, and it never hits the stop. Why? It's because it got to here, and it said, is it different than 9? Yes, true, it's different than 9, and so we got to the exit function and it took us out of here. I'll put that 0 back in, just so we can see that that's working. How are we feeling with this part of the code so far? Question? You got a question on numbers only, go ahead. So the question is, where does data get its value? Okay, so data it's a variable. It's a special variable called a parameter that's defined right here inside these parentheses. And so now the way this gets its value is when I call numbers only, I have to send it something I got to send it some value to go into data. So here's where I'm calling numbers only, and I'm passing in the book number. And so when I call the function and I put that inside the parentheses, that's how I tell it to assign that value into this variable. Okay, so now I think we're ready. We're ready to implement that algorithm that we saw on Wikipedia. Whew. First part was a lot of work. We got to take 10, and we got to multiply that. In this case, we got to multiply it by 0. Add that on to 9 times 3, add that on to 0 times 8, add that on to 6 times 7. Whew. I'm going to do this with a loop, but I'm going to show you a little trick that's really helpful when you're just starting with loops. Instead of starting with the loop and trying to figure it out, because the loop is more abstract than writing these lines individually, I'm going to write the first 4 lines as if I was going to write them all. And the truth is, it's only 10 lines. I could write them all, just write the 10 lines out. But part of this is to get some experience working with loops. And so let's just go ahead and dive in. I'll work above my little stop here. Oh, I'm going to need another variable to kind of accumulate the values here. So let me dim something called checksum as an integer. Integer will be plenty big for what we're doing here. All right. So how do I help me write the statement that will do the first part, that first part of the algorithm right here. Take the 10 times, take the 0 and multiply it by 10. And just kind of put that into my checksum number. I'll get us started. Checksum equals 10 times something. What? Okay, I need the first digit off of my book number, my BN variable. So how do I get that? Left of BN 1. Very good. Now, only problem here is that this is a string and this is a number. So if I come up here and say I just want to take some number 2 and I want to add it to some number 5, what is that going to give me? Because those are strings, it turns out that the plus operator is defined for numbers and for strings. If I have 2 arguments that are strings and I tell it plus, it's going to do concatenation. If they're both numbers, it'll do addition. But what if one's a number and one's a string? It goes, I don't know what you're talking about here, but there's no mixing and matching here. And so it converts one into the other. Now, did it do that because the number was first and the string was second? Or did it just because one of them was a number? And it thinks if one of them is a number and I convert the other one to a string, I bet we're going to do it that way. Yeah, it's not the order. It just says, you're doing addition, you've got a number and you've got a string that could be a number, it's addition. You're doing addition and you've got a number and you've got a string that's not a number, it's I thought that was going to do it. It's an error. Okay, so let's move on. But the point is here, it turns out that multiplication isn't defined for a string variable anyway. And so it's going to make the conversion for me. If you really wanted to, you could say convert to int. And you could expressly do that. I'm going to leave that off just because it's simpler without it. And it's going to do the conversion automatically. Okay, so I got the first one. Now I want the next step. In my next step, I'm going to make checksum go a little bit bigger. So checksum is going to equal what it used to be plus something. Okay, what's it going to be plus? I'll get us started. 9 times what? Mid of Bn, starting where? 2, and taking 1 character. Okay, so now at the end of checksum, it's going to have whatever this one first gives it. In our case, it's a little bit strange thing because it's going to still be 0. Now the second time, we're going to take, it's going to get a new value. What is it going to be? 0 plus 9 times 3, so it's going to go to 27. Okay. So what's going on here with mid? So we're looking at our whole candidate here, which is, it's this without the hyphens in it. And it says, look at that, and look at the second character, which will be the 3, and bring back 1 character. So this expression is going to give us the 3. Okay, let's do 2 more lines. This is going to get easy right here. So this one is going to be 8. This one's going to be 7. And we're going to be moving 1 deeper into my book number each time. That's going to be 3. That's going to be 4. Now, as I look at these, I look at that and I think, wow, I look at those next 4, and those lines look really similar to each other. In fact, they're all exactly the same except for what's in this position and what's in this position. And in both cases, those are a really simple numeric sequence. That was like custom made to make a loop. This first one, maybe this first one belongs outside of the loop because it doesn't look like the other ones at all. But before I'm so hasty as to say I'm going to do that outside of the loop, could I convert this one to make it look really similar to the ones that are in the loop? What do I do? I see some nodding. What do I do? Yeah. I'll just turn this to mid. I'm going to start at 1, and I'm going to take 1. So now that part looks, this part looks really similar. What else could I do? Yeah, I can actually come in here and just say, you know what? Let's put the checksum here too. Checksum is what type of variable? Integer. What's the default value for integers? 0. So the first time we said this, we're saying checksum is going to equal 0, what it currently is, plus what the result of this is. So now they're all the same. Oh, that looks great. So now I'm ready to make a loop. Okay, so I'll need a control variable for my loop. So I'll just do dim x as an integer. And I'm gonna copy this first line so I can leave the 4 in place that I'm looking at, and then start to generalize this one for the loop. 4x equals 1 to what? Length of my book number. Oh yeah, even better than that. We already know how long it is. It's got to be 9. Yeah, I like it. No reason to ask. It's 9. Thank you. And I'll go ahead and put the next in. Remember, next is going to add 1 to x each time through the loop. All right. So now, as I look at this, I can see, I don't think I can actually add space into these. The editor will take it out. So I can see I've got one sequence here that goes 1, 2, 3, 4. I've got another sequence that goes, 10, 9, 8, 7. I already answered that question. Apparently, I've decided to use x to give me this sequence of numbers. The first time through the loop, I want x will be 1. Second time through, it'll be 2. Third time, 3, and so forth. So How do I modify this line to make that part happen? Yeah, I'm going to replace this 1 with the x. The first time through this loop, x will be 1, and so this line will say, it'll have a 1 in that position. Second time, it'll be 2, then 3, then 4, all the way up to 9. Now, I've got to have some other expression that where the 10 is will give me 10, 9, 8, 7. Okay, I could make another variable. I could make a variable called y. I could start it off at 10, and inside my loop, I could subtract 1 off of it. So the next time through the loop, it would be 9, and then 8, and then 7. I'm not sure it's a simpler way, but there's a more elegant way to do that, a different way that I could get at that sequence. In the back? 11 minus x, right? Because if x is 1 here, I take 11 minus 1, that'll be 10. X is 2, 11 minus 1 is 9. Or 11 minus 2 is 9. When it's 3, 11 minus 3 is 8. So instead of 10 here, in parentheses, I'm going to say 11 minus x. And that will now give me this same sequence that I built by hand here. By the way, I built it by hand just so I could get a look and see what the sequence of numbers is. It's just a technique that while you're getting used to working with loops, it can be really helpful to see what has to be done. And so even though I went through all that work to make these 4 lines, I don't need them. Okay, I think I'm ready to run that. So let's take a look and see what is my check digit, comma, what is my book number, comma, and what is my checksum. So 2, and then my book number there, and then 130. Is 130 right? Let's go back and look. Oh yeah, 130 is the value that we're getting in, that we needed to get to there. Looks great. Next step of the algorithm is inside these parentheses. I got to take 130 mod 11. Now, I don't need my 130 for anything else. It's just this interim step, so I'm going to keep doing it inside my checksum variable. Checksum equals checksum mod 11. So I should be able to just drag back up to that line and run it. And take a look at what my checksum is now. Checksum is now 9. Is that what we had there? Yeah, 9. So the next part is 11 minus 9. Okay. Checksum equals 11 minus my checksum. That should get me to my 2. I'll run that. Oops. And see what it produces. There's my 2. And now my last step is that number mod 11. Yeah, it's a good question. I don't have any idea how the guy who thought of this thought of it. But that's what he came up with. There it is. Okay, so now I have successfully I've done the whole algorithm. Am I done? What's the next step? I've now calculated the 2, right? If I look up here, I'm passing in this whole number. And ultimately, I have to make it a ruling. I have to say, is it a valid number or not a valid number? In the back? Yeah, I've got my check digit sitting off the side of a variable called CD. I just got to check to see if it's the same one. And so, but I still have a special case, and that is when my checksum is 10, what's the check digit supposed to be? Yeah, it's X. So let's get started on that one first. So let's do this. Let's say if checksum is equal to 10, we'll do something. Else if checksum is equal to my check digit, we'll do something, and if. Okay, let's do this one first. What does it mean if the checksum is equal to the check digit at this point? You passed in all this number that had a 2 on the end. I looked at everything besides the 2, and I calculated a 2. These 2 match. What does that mean? It's a valid ISBN. And so I'm now just going to say is valid ISBN 10 equals true. Okay. Now we have a little more looking to do if our checksum is 10. If our checksum is 10, what do I have to look at? Yeah, if my check digit is X. So now if this is 10, I'm going to say if my check digit is equal to X, then we got the same thing. Is valid ISBN 10 is true. I have one more kind of small problem here. What is it? Maybe it's a big problem. Maybe it's a capital problem. Well, X isn't a number. That's okay because it can come in as a check digit, can be an X, meaning 10 is a check digit. It's a low, well, yeah, what if the user types in a lowercase x? That's a reasonable thing to do, don't you think? So how do we make this into a case-insensitive comparison? There's actually a function for comparing strings in a case-insensitive way called string compare, string comp. It's a horrid function. It's horrid. I think it's a really poorly designed function. There's kind of a simpler way. I'm just going to take whatever they passed in, which I have in my check digit, and I'm going to force it to be uppercase. uCase of CD, I'm not changing it. I'm just saying, call the function called uCase, send it the check digit, and it will come back as the uppercase version of it. So now I can check that against uppercase X, and I don't have to worry about lowercase. If it was lowercase before, it's been uppercased. Okay, that looks pretty good. So now the only situation that we're going to return true is if we calculated 10 and it was an X, or if whatever we calculated is what it was. I like it. Let me get rid of the stop. And whoops, let me get rid of the stop. Stop my code. And I should be able to run this, and it should now print true when it's right. And if I change the check digit to anything else, it should print false. Oh, delightful. And we could kind of fiddle around and see all the things that we expect to have a check digit. Transpose any two numbers, change any one number. The last thing I want to see is how do I call this from inside of a cell? So let me take this, bring it over here to a cell. And I'll put it in twice, one with it being correct and one with it being incorrect. And now I'm just going to call it from right here. Is valid ISBN 10. It shows up in the list of things I can choose from. How slick is that? I tell it that's the cell that's got the value. Copy it down. And the ones that are valid, it shows valid. The ones that are invalid, or ones that are valid shows true. Ones that are invalid shows false. Delightful. Any questions? Is that far enough? Okay, remember your next project is just like this. You now have everything you need to be able to work on that next project. Feel free to get started. Thanks for coming. Class dismissed.